Welcome to Lesson 7 for Mizzou Biology B. In Lesson 7, we are going to be talking about acids and bases, and this is another chapter that I consider to be a hard chapter because it does not make any sense at all if you haven't made sense of the chapters before. You're going to see equilibrium again, and you're going to want to be friends with your stoichiometry as well. There's a lot of different topics, and they're all pretty mathy. But first, you're going to be talking about the definition of what acids are, and they're ubiquitous. They're all over the world, right? They're inside of our bodies, they're in the atmosphere, they're in our water, and so there's a lot of chemistry that happens because of these chemicals that is important to know because it relates to a lot of great concepts in more advanced science classes. So learn about how we define acids. And when you look at conjugate acid-base pairs, I think that part's easy. You just find two formulas that are exactly the same, except for a missing hydrogen on one of them. You are going to be looking at K again, and here's a K that I have not shared with you before, K sub W. I like to think of it as K sub water, but it's the ion product for water. And it's just the concentration of hydrogen ions times the concentration of hydroxide ions in any aqueous solution. And a really cool thing about this is that, there it lights better, I think. A cool thing about this is it's always going to equal 1 times 10 to the negative 14. 1 times 10 to the negative 14. And so if you have an aqueous solution and you know maybe your concentration of hydrogen ions, then you can solve to find the concentration of your missing ions. And don't forget, in case you missed it, whenever you have a K or equilibrium, the only thing that goes into your equilibrium expression is the ions that are in the aqueous phase or the molecules that are in the gas phase. Those are the only things that are affected when we talk about equilibrium. You're going to move on to pH. So we're going to be using the log button on your calculator, so that might feel a little intimidating, but it's not. Log is just power to the base 10. So what's the log of 1,000? 3. Because how many 10s go into 1,000? 3 of them. 10 times 10 times 10. So when you're looking at pH, it's just looking at the general amount of hydrogen ions. Concentration is our friend. Molarity is our friend. Don't forget those two. Sometimes I think about P as per. pH is just per hydronium or hydrogen ion concentration. Miles per hour, mph. pH per hydrogen ions in this case. And then you can do a little bit of algebra. This is just algebra. And if you want to know, well, I know my pH. I want to know what is my concentration if my pH is 2.77. Then it's just this equation. You're just going to say, well, what's my hydrogen ion concentration? Anti-log. My calculator is 10 to the x. Most of the time, anti-log is just saying inverse log. So probably second log to get the anti-log. So concentration of hydrogen ions is anti-log times negative pH. Pretty cool. You're also going to be looking at strong and weak acids. If you think about equilibrium, then it makes sense why we make a difference between the two. Strong acid like hydrochloric acid is going to completely ionize. So we're even thinking about what we know about our solubility rules from those last two chapters, and even going back into balancing equations. So your strong acids, memorize which ones they are, and you see it's a single arrow because there's not an equilibrium. If I start with hydrogen chloride and mix it with water, the HCl will break down completely into hydrogen ions and chloride ions, and we call that solution hydrochloric acid. But look at how it's different from a weak acid. Weak acids, in order to understand those, you need to know your equilibrium, because weak acids, before you have just acid, just HA, but after you mix it in with water, you have mostly HA, because acids are molecular compounds even though they ionize. But a little of it ionizes, kind of like water. Water can act like an acid. So with a weak acid, You get the double arrow, you have an equilibrium. You can call it Ka if you want to, the equilibrium constant for the acid. So for a weak acid, it's molecular. Mix it with water. Some of it breaks down into hydrogen ions, and some of it breaks down into whatever the hydrogen is attached to, the anion. You're also going to be talking about neutralization reactions, which, if you remember, the vinegar plus the baking soda. Vinegar is an acid, baking soda is a base. Mix the two together, and if I had the right proportions, they would be neutral. So find out about that. This is another chapter that when you get into college or AP, it's probably going to be broken down into 2 chapters so you can get into more details. But you can do it. Keep your algebra steady. Email me for anything. Bye.